going to make the base, or part number 9, on the mill, and I have just verified that my vise was indicated properly, so I'm going to remove my indicator now. I'll put it securely back in the box that it came out of, because remember, these guys are very fragile. And now I'm going to need to prepare to use an end mill. That means that I'm going to have to remove the drill chuck, because we never use an end mill in the drill chuck. Remember, I cannot stress this enough, you never use an end mill to mill in a drill chuck. A drill chuck is used to drill things. It is very good at cutting in an axial manner, meaning that I come straight down and straight back up. If I put a load on the side of anything held in a drill chuck, it can become a very dangerous situation. You can damage the drill chuck, and you can lose grip on the tool that you're holding, and it can come flying out. You can rip your part out, you can rip your tool out, you can destroy the chuck. So none of those are good things. So we need to remove this and replace it with either a collet or an end mill holder that has the set screw in it. So to remove this, I'm going to loosen the drawbar. And before I back the drawbar all the way out, you'll notice that it is wedged into the spindle. That's normal. You need to take a hammer, a dead blow hammer or a brass hammer, and give it a quick rap on the top of the drawbar, and that will break that loose. Now I can continue to loosen it up. Again, a key thing to remember is to not loosen the drawbar all the way. You want those threads engaged in the top of the tool holder so that, one, this doesn't come flying out when you hit it with the hammer, and two, the threads at the top of the tool holder and at the bottom of the drawbar don't get damaged. Now I'm choosing to use a collet. I need to align the keyway in there, and I'm going to start tightening this up by hand, but it is still loose, and I'm going to fit my end mill into the collet. Now it's very important that you do not tighten the collet with nothing in it. It will bend the collet legs and permanently deform the collet, which is obviously damage to the collet. Now I can tighten that up, and once I have snugged it up by hand, I can use the wrench to tighten. Once I have tightened the drawbar, that end mill is now very securely in the spindle. So I have my tool in here. This is an end mill. I have chosen a 3/8 inch diameter end mill. Honestly, it really doesn't matter what diameter end mill you choose. However, your RPM calculation will change based off of the diameter end mill you choose. I would suggest for this particular part that you choose an end mill wider than 1/4 of an inch, and that will become apparent here in a moment why I'm saying to do that. So the first thing that we're going to need to do whenever we are machining the base is we need to square up this piece of aluminum. When I say square up, I may or may not be referring to an actual square. In this particular case, our print shows 1.5 inch by 1.5 inch, which is an actual square. But when I'm referring to squaring a piece of material up, I'm referring to all the edges are at 90 degrees. So I've got 90 degrees here, 90 degrees here, as well as 90 degrees here and here. The first thing I'm going to do is I'm going to select an edge to cut off. I can rest the material down in the bottom of the vise if it's tall enough, but in our instance, we can see that the top of the material is right at the top edge of the vise. And that's not good. If we go to cut across that, we could cut into the top of the vise jaws, and we don't want to do that. So what we need to do is raise the material up. And in order to do that, we're going to use something called parallels. Now, if you look in your toolbox, you'll see a set of parallels. And what these are parallel plates. They're pieces of steel that are ground to be parallel to each other or the same height. Parallels function in the machine shop as elevators and bridges. I'm going to wipe these off so that there are no chips or debris on there. And I also want to wipe off the interior of my vise to make sure everything is clean. Now, if I put these in there, I can set my plate or my piece of aluminum on top of it and raise it up. However, there is a bit of an issue with using both parallels right now, in that these parallels are 1/8 of an inch nominally thick each. So if I put two of them together, nominally it's 1/4 of an inch. Now there's a tolerance on these, just like there's a tolerance on this. So if I have something that is 1/4 of an inch thick and something else that's 1/4 of an inch thick, you honestly have no idea which one it's going to grab, because nothing is perfect, as I have stated before. Everything is variable. So this is not exactly 1/4 of an inch thick. Neither are the two of these. It might be 250,001, but it's not perfect. So we always want to make sure that what we're cutting is what we hold on to. So I'm going to take one of these, set it aside, use one parallel in the bottom of the vise, and that's going to do two things for me. It's going to raise it up, and if I want to clamp it in the middle of the vise, it's going to bridge this gap. So this is serving as a bridge and an elevator right now. And you can see if I do that, I've got much more material sticking up that I can work with. So I'm now going to clamp the vise on this piece of material. I'm just closing the vise down where I can get to it. I want to get that where I'm ready to clamp it, and prior to ever machining anything in the mill vise, you want to make sure that you have already deburred completely your part. If you feel any burrs on your part, this is the time to go ahead and make sure that you have removed them, because any burrs at this point are going to do two things. They are not going to allow your part to sit flat, and if the burrs come out in this direction and you're clamping it like that, it's going to serve as basically a hinge, which means that you're not going to be able to adequately clamp your part. So, I've checked for burrs. I've got my part sitting securely down against my parallel, and I'm going to clamp my vise. And I always try to pull the part out of the vise whenever I do this, because if I can move it, I promise you, when you start machining on it, it will move. Now, I don't want my parallel box to be full of chips, so I'm going to close it up and set it back over here. And now, I need to position my tool over my part. I'm going to bring my quill down a little bit, and I need to raise the table to meet the tool. I'm going to move the vise to where the tool is over the part. Now I have moved my tool down very close to the part, but it is still hovering over the part. And what I am doing is I am looking to see that the part is roughly centered on the end mill. Now I'm going to be feeding the vise in this direction while I am machining. So I want to lock down the table locks in this direction of feed. That table lock is over here. I want to lock that. So now that's not going to move. The reason I want to do that is because of the backlash in this direction. I want that table locked down so that this thing can't shift back and forth while I'm machining. In order to prepare for this cut, we have set a parallel in the bottom of the jaw of the vise, put our part on top of it, and we have also set our RPM to the proper RPM. Now this is a 3/8 inch diameter cutter. It's a high-speed steel cutter. This is a piece of aluminum. So our RPM calculation would look like 4 times 300 for the surface feet divided by 3/8 of an inch, because the diameter that we're cutting with is 3/8 of an inch, because now we're moving the cutter. So it would be 4 times 300 divided by 3/8. Our machine actually won't go that fast, so I'm going to be running it in high gear on the 1/1 setting, which will give us 1550 RPM. Remember, you can always run things slower if you need to, but you don't want to exceed the RPM. In order to help see whenever we make contact with our tool, I like to take a Sharpie and just color the top edge of my part. You don't have to do that, but it is a visual aid that will help you whenever you're getting started. So we need to find where the point is that our tool touches our part so that we can set a 0 and start working from there. So what I'm going to do is I'm going to start the spindle running, make sure that it is running in the clockwise direction, choose the forward high or forward low setting. I'm going to position my tool over my part, and now I've got my quill locked in place, and I'm going to raise the bed until I just see the tool first make contact with the part. I'm going to do that by raising the knee. You can hear it and see it. There we go. Now that is my 0, so I will come down here and set my part 0. And now I can control how much I take off per pass. I'm going to use a little bit of cutting oil. I'll put a little bit on the tool and a little bit on the part. And I'm going to raise the knee up about 20 thousandths of an inch, because all I want to do is to clean up the top surface. I may have to repeat that if there's a serious deviation from a straight line or if it's at an angle, but 20 thousandths is usually a pretty good starting point. I've got that, and now I'm going to feed the part beneath the tool. I'm going to work on this handle over here so that you guys can see good. I need to use the right hand rule to figure out which way to turn my handles. I'm going to push the vise away from me so I can use my thumb on my right hand, point it in the direction I want to feed, and the direction that my fingers come out of my hand is the direction I want to turn the handle. So I'm going to turn the handle like that to push the vise away from me. I'm going to slowly and consistently feed the total length of the part. Whenever I'm finished cutting all the way across, I can feed back to the other side. I can turn the spindle off, and if I want to, I can use the brake to assist in slowing the spindle down to a stop. I can now examine the surface that I just cut and see if it cut the entire surface. If it did, I can look at this and tell that it did cut the entire surface off. What I'll do is I'll use a chip brush to clean off any excess chips from the surface. And I can now release my part, get a better look at it, and the first thing that I need to do is deburr this part. This is something that you're going to have to do in process because we're going to flip this part over. Don't forget these little short edges. So that edge is now the edge that I just cut. So what I'll do is I can put a mark across there to let me know that that edge has already been cut, just as a reminder. You don't have to do that. It helps to show up on camera. So this is the edge that I just cut. I'm going to take that edge and put it down against the same parallel that I just had in. Now, before I do that, I'm going to open my vise up a little bit, and I'm going to check to make sure that I don't have any chips or debris in my vise. This is a very key and important step to success on the mill. You always want to make sure that you are successful at cleaning in between each time you take a part in and out. Be careful reaching around the end mill. Always make sure that the spindle is off, and use care when reaching beneath the end mill. They're sharp and they will cut you. Now I wiped off the vise and the parallels and my part. I have cleaned off my part to make sure there's no chips and debris on my part. Now, this is the edge I just cut. I'm going to put that edge down, and I am clamping it again in the center of the vise. The reason I'm clamping it in the center of the vise is that it is a more secure work holding, and if you can, which you can't always, which you'll see in a second, but if you can, holding it in the center is a preferred place to hold it in the vise. That way the line of force from your screw generating the clamp force is in line with where you're clamping. So now I have flipped that part over, and at this point the bottom of the end mill should be at approximately the same height as the top of my part. What I like to do is go ahead and put some cutting oil on my part and my tool, turn my tool on, and just take a quick pass across there to make sure that it is at approximately the same level. Now you may see a little bit of a cut go on, just very, very light, but it should be almost non-existent. As you see, there's only one tiny little section on there where it even made contact. So that's good. I'm going to now raise the table another 20 thousandths so that I can try to cut that entire edge. I'm going to feed across just like I did before. And we'll examine the surface to see if the entire edge was cut or not. I can look at it and see that the entire edge was cut. I'm going to take my part out and deburr it, and then we're going to measure the part. Deburring your parts before you measure them is a very important step because you don't want to measure across burrs. They can give you false caliper readings. Well, so I'll wipe this off so that I'm not measuring on any chips or burrs. I will get my calipers and measure the surface that I just cut. I like to measure it on both ends, and I am measuring this at 1.591 on this side, and measure it on this side as well, and that's 1.591, and what that tells me is that the two sides are parallel. A lot of times you'll see people measure it like this, and that's fine if you know that your sides are parallel, but I think it's important when you are first starting out to measure one end, measure the other end, and verify that the edges are parallel. I need to wipe my vise out again because I've taken my part out and I can see that there's some chips and oil down in there. And my parallels. Now normally you probably won't have to open the vise that wide. So my part is back in there nice and tight, and we haven't changed any of the height stack that we have going on, so this height should be at the bottom of that tool. What I'm going to do now is to set my zero on here. I'm going to set my zero, and this height was at 1.590, or 1.591, I'm sorry. So that means, if I look at my print, it says 1.50, so that means that I need to take off 0.91 inches, or 91 thousandths of an inch. I can't do that all at once, okay? I would suggest that you limit your depth of cut when you're cutting across there, when you're starting out, to be 25 or 30 thousandths of an inch. You can safely cut more than that. I'm going to go ahead and mill that down. So I need to take off 91 thousandths, so I'll probably do 40, 40, and 11, because that would be 91 thousandths. So there's 40 thousandths. A little bit of oil. finishing pass, I'll move up 11 to 91. Then I'll use my chip brush to help clean away some of those chips to keep them from getting down in the vise again. I'll unclamp my part. Deburr it with the file. Off. Make sure I don't have any chips and debris on there. And then we're going to measure. I am at 1.501 on that end, 1.501 on this end. So I am at 1 inch 501 thousandths. And if I look at my print, I have 1.50. And if I look down into the title block where the tolerances are, it tells me that a 2 decimal place tolerance is plus or minus 10 thousandths of an inch. So I'm good, and that means that I can move on forward to the next step, which is going to be trimming the opposite edges. Now, I can't just turn it 90 degrees because I don't know that this angle, well, I can guarantee you that this side is not square to this side because it's just a saw cut. So it's not going to sit perpendicular if I just turn that approximately 90 degrees and let this rough cut edge sit on there, because it'll move one way or the other because it's just a saw cut. So what I have to do is I have to figure out a way that I can orient this part so that this edge and this edge will be 90 degrees to each other. One of the methods that I can do, and if you have a bigger part, this is something that you might do, is I could just set it in the bottom of the vise. I'll take that freshly machined edge and I'll put it against the back jaw of my vise and clamp it in, with it securely sitting on the bottom of the vise. Now, that will work if your part is tall enough. However, we're going to run into issues with being able to reach this part because of the spindle and the quill and everything is going to start to get in the way of possibly hitting our vise. So we need to raise this part up. This is where your parallels come in. So I can open the vise, get a taller set of parallels than what I had before, and now you're going to have to use both parallels because we want to hold the part up higher and it's wider. So what I like to do is just look at the parallels and find a set that is pretty tall but still allows me to hold on to the majority of the thickness of the part, which these look like they're going to do the job. Again, I'm going to wipe my parallels off because they may have oil or something from the box. I'm going to clean my vise. Wipe this parallel. Clean my vise. Now, the optimal place to put this would be in the middle. Right? Because my clamp force would go right through the middle there. However, we won't be able to cut that entire edge. We can't reach that edge. So we're going to be forced to come over to the side of the vise. We want to leave some of the edge of the part sticking out so that we can get access to it. And we want to make sure that the parallels are not beneath the edge that we're going to cut, because we don't want to hit the parallels with the end mill. Now I'm going to move over and I'm going to lower my quill. And I'm going to position it where the bottom of the end mill is just below the bottom of my part. And we're going to use the side of the tool now in order to cut this 90-degree angle on there. Now we have to keep in mind which direction we want to feed it, because we want to be using conventional milling techniques. This is a conventional machine. So if I were to look at the spindle, it's spinning like that. I can either feed this way or this way. I can push the vise away from me or push the vise toward me. I need to release my table lock. And if I start down here, my cutting force is going to be pushing this way, and I'm going to feed the vise back toward me. They're opposing. That is conventional milling. So this is where I want to start, and I'm going to work the vise back toward me. Now, in order to find out where I'm at and position my tool, I need to turn the vise on, or turn the power on, and feed up very carefully to where I start to notice some chips come off. There we go. I'm going to put some oil on my part, put it on my tool. I'm going to feed into my tool about 20 thousandths. This is very, very similar to what we just did. I'm going to set my zero here. Feed in 20 thousandths. And now I don't want my part to move in this direction, so I'm going to lock my table locks in that direction, and I'm going to feed it in this direction. So I'm going to feed the vise toward me. Before I feed back, whenever I'm side milling, I like to put a fresh coat of oil on there just to help keep things clean. And I'm going to look at that side and see if the entire surface was cleaned up. It was. So now I can loosen my table locks. I'm going to back up. And I'm going to flip the part over or around, however you want to think about it. Wipe it off. I still need to deburr it each time. One of the things that you will notice When you change the orientation of your part and you're cutting on the side versus the end, is that the lay or the tool marks that are left on the part are going to look differently. When you are cutting on the side, you'll notice that they are like straight lines. And when you are cutting on the end, you'll notice that they're little spirals. Now there again, I'm just going to wipe everything out. Make sure I don't sit everything down on the chips. And spin this around. Clamp the part securely, and now we're just going to repeat that same process to square up the part, but I'm not going to take the part out at the end of this particular motion. Well, I need to set my 0 and feed in 20 thousandths. Lock my table lock, and now I'm going to feed the vise toward me to clean up that side. Look and see that that side has been completely cleaned up. And I'm not going to take it out at this point. I know now that that side is completely cleaned up, so I'm going to actually reset my 0 over here, because I know that that's a nice clean edge, and that's where the tool stopped cutting. And while my part is still in the vise, I'm actually going to deburr this part in the vise. Now this will take you a moment. Make sure you get the top and the bottom edge, which can be a little bit tricky, but that's okay. Just takes a little bit of time. And we're actually going to measure the part while it's still in the vise. And what I am left with is 1.640. So I'm at 1 inch 640 thousandths, and I want to be at 1 inch 500 thousandths. That means I need to take off 140 thousandths of an inch. So I'm going to do that, and whenever you're side milling with a tool of this size, you're probably going to be stuck with somewhere in the neighborhood of about 30 thousandths of an inch being the deepest cut that you can take. So I'm going to start cutting and keep up, and I need to take off 140. So I'll do 30, 30, 30, 30, and then do a final pass of about 20. So we'll measure right before we do that last pass. This move right here is just to take me back to the other side. I'm not actually cutting anything. I can release my table lock. I'll move about 30 thousandths of an inch. Release my table lock with another 30 thou to 60. my table lock, go to 90. Put a little more oil on there. Table lock, we go to 120. Now, if you trust your numbers, you can go on and take your last cut, but being new at this, I would suggest that you take a moment, deburr it, and verify that your last cut actually needs to be another 20 thousandths removed. So I'm at 120 right now, and I should see that I need to go about 20 thousandths more to hit my desired measurement. We'll take our measurement, and we will see that I am at, I am at 1.521, so I need to take off 21 thousandths to get to the number that I want. So I can feed this in. Fresh oil, a little bit on the tool, a little bit on the part, release our table lock, and we're going to feed in 21 thousandths. Clamp our table lock again, and we've put some oil on there already, and we will carefully feed across for our final pass. Take our measurement and verify that we hit the dimension that we were going to hit. And I am at between 1.499 and 1.500. So I'm within 1,000 of where I want it to be, which is well within my tolerance. So now we have a square, and it is 1.5 inches by 1.5 inches. If we look at our print, we have another feature on there, which is a hole and a countersink. I can't just use the countersink because if you recall, a countersink puts a beveled edge on an existing hole. So I've got to put the existing hole in first, and I'm going to swap out for the drill chuck, and we'll be right back. When you're ready to switch between an end mill to another end mill, or between an end mill and another style tool holder like the drill chuck, which we're about to do, you'll need to remove the end mill. And there are a couple of things that you'll want to keep in mind. The first thing we need to do is loosen the drawbar so that we take pressure off of the collet. Just like whenever we take the drill chuck out, we want to make sure that we don't unthread the drawbar all the way. You're not going to get the end mill out because just like whenever we had the drill chuck in there, it's going to be stuck up in there. We're going to need to use a hammer and knock it out. However, if you just use a hammer and hit it, there's a good chance that the end mill will come shooting out of the bottom, and we don't want that. You'll damage your tool. You also don't want to just put your hand under there to catch it because it could cut you. So what I like to do is I'll fold one of the shop towels up and put it underneath to cushion my hand and give it a wrap, and then I can pull the end mill out with the shop cloth, and now we can take the collet out and replace it with the drill chuck. We've got our drill chuck in there. Now we have to figure out how we're going to position this hole. If we look on our print, it says that the hole is 750 thousandths from one side to the other. We know that because it is shown with center lines, and the center of 1.5 inches, or half of 1.5 inches, is 750 thousandths of an inch. Now, if your part came out a little undersized, and you decided to use it, let's say it came out to 1.4 inches instead of 1.5. You could still use that part, but you would want to divide whatever that number is in half and put it on center still. Mine is 1.5 by 1.5, so I'm going to use 750 thousandths of an inch. In order to find that, we can use a tool called an edge finder. And an edge finder allows us to find the edge of a part relative to the center of the spindle. Each edge finder has the potential to be different, but the edge finder that I have and the one that you should have in your personal toolbox, the end that we're going to use to measure should measure 0.200 inches, or 200 thousandths of an inch diameter on the end, which means that from one edge of the edge finder to the center of the edge finder is the radius of that, or 100 thousandths of an inch. I'm going to put the edge finder in the drill chuck and tighten it. And we're going to come down and position ourselves where the edge finder is on this edge first. It ultimately doesn't matter which edge you find first, but I find this method just works out well. So I'm going to come in and I'm going to bring the edge of the part toward the edge finder, and I'm going to do that in the high gear as far as your RPM goes, and high gear on here. So it's going to be spinning at as fast as this mill will go. These edge finders work well at higher speeds, somewhere between 1500 and 2000 RPM. When I turn it on, if I bump the edge finder just a little bit, it may not show up well on camera, but there's going to be a little bit of a wiggle to your edge finder. I'm going to feed the part toward me until I see it kick to one side. So if you see, there's a small wobble right there. We're going to feed the part toward the edge finder. And as we get closer and closer, that wobble will start to go away. And at some point right there, the edge finder jumps to one side. You'll notice that edge right there jump to one side. At that point, I'm going to set my dial on the handle to read 100 thousandths of an inch. The reason I choose 100 thousandths of an inch is because that is how far I am away from the center of the spindle. The radius of the edge finder is 100 thousandths because the diameter of the bottom of the edge finder is 200 thousandths. Now we've zoomed back. This is where we left off with the edge find. This is an edge find in the Y direction. I'm going to move in the X direction to where the edge finder is clear of the part. And I'm going to now move the part toward me, that 100 thousandths of an inch, to 0. And now the center of the spindle in the Y direction will be in line with that bottom edge of the part. I know that I want the center of my hole to be 750 thousandths from that edge, so I'm going to go ahead and move another 750 thousandths of an inch from my 0. Each revolution of the handle is 200 thousandths of an inch, so that's 200, 400, 600, and then 750 thousandths, and I'm going to lock the axis of travel in this direction so that it can't move anymore. I'll set my table up. I'm going to repeat that exact same process in the X direction now. Approach the edge finder and watch for it to kick to one side. Just did. Stop my spindle. Set my axis to be 100 thousandths. At this point, I'll raise my spindle because I'm going to be feeding the X-axis across where the tool would actually be sitting at this point. So I'm going to, remember, feed with your right hand rule to my 0 point, and you'll see that the center of the spindle should now be over that edge. And I'm going to feed in 750 thousandths from that edge. 200, 400, 600, 750 thousandths. And I'm actually going to set that table lock as well. Now I'm going to change from my edge finder to a center drill. The reason we choose to use a center drill is so that it starts the hole. And before I turn my machine spindle on, what I like to do is go down and put a small mark on my part just by hand. You guys can see that on the camera there. But the reason I do that is so that I can use a pair of calipers or a scale, and I can verify that the hole is going to end up in the correct location. I can open my calipers to be 750 thousandths of an inch, and you're not going to be able to scale to a thousandths with a small mark like that, but it will definitely show up if it's incorrect. So I can just go from one edge to the other, and you can see that the hole is going to be in the correct location. So at this point, I'm pretty sure that I'm putting the hole in the correct location, so I can use my center drill. The drill bit that I'm choosing is a 200 thousandths diameter drill bit. This method is called peck drilling because I'm pecking at the hole, and what that allows me to do is to come back and retract to get the chips out of the hole. Now, one thing that you need to ensure yourself of prior to drilling that hole is that there is nothing beneath the part that you don't want to drill into. If you had a narrow part and you had parallels under it that you could drill into, you need to move the parallels. If you had this sitting on the bottom of a vise, you wouldn't want to drill all the way through your part because you'll drill into the vise. So always be sure of what is beyond your part to make sure that you don't drill into something you don't want to drill into. So I can take the drill out, and now I can swap over to the countersink. Now the countersink we're going to want to spin at a lower RPM, so I like to use the low speed setting. And what we're going to do is we're going to come down, put a little bit of cutting oil on there. And go down, and what we'll do is we will use one of the screws as a gauge to see if we have went deep enough. I would urge you to check it more often than less often. That way you don't go too deep. What we're concerned about is getting that hole to be just below the surface right there. And if you look, nothing is sticking up beyond that surface. The way that you can check that is you can take a straight edge of some sort and move it back and forth, but I can clearly feel that my screw is just below the surface. That's exactly where I'd like to have it. And at this point, what we can do is we can take the part out and deburr it. One of the things that you're going to want to make sure of that you deburr is the back side of this hole. If we take the part out and flip it over, I can remove my countersink and just use the countersink by hand to deburr any burrs that come out of the back side of that hole. And if you feel any burrs on any of these edges, there might be a few left over that you didn't get real well because it's awkward to get to with the file, we can then finish deburring that part, and this part is finished. One of the other sets of parts that we're going to do in this lab are part numbers 1 and 2, but we are not going to fully machine those parts. All we're going to do is take those parts to length. While you have your setup, you can put your steel part in there like that. You're going to need to make sure that you change your RPM to match the RPM for cutting the steel. and we will bring an end mill across in a collet or an end mill holder across that end. We'll take it out, flip it over, and then we can take it to length the exact same way that we did with the aluminum piece, and that's all you have to do. Just take part numbers 1 and 2 just to length.